So in this video, I'm going to solve two challenging trigonometry problems. When you see these on the Regents, they're usually one of the last problems, probably number 34 or something like that. So first I'm going to show you how to solve for x. I'm not even giving you a context here. I'm just giving you the triangles, all right? But they'll give you a context. They'll give you a word problem. So in this problem, I want to solve for x. That's my goal. But you can see there's three triangles in this picture. The triangle on the left, the triangle on the right, and the outer triangle. One way that we can go about solving for x, okay, and I'm going to show you two methods. I can call this y. If I name this side y, then this entire side would be 150 plus y. What I could do is I could use the right triangle on the right and use the outer right triangle. So if I use the right triangle on the right, and you may want to take it out of the picture, this is 48, right? This is x, this is y. So I'm going to set up a relationship. Tangent 48 equals opposite over adjacent. Remember? So, toa. So tangent is opposite over adjacent. Now if I take the large outer triangle, this is 35. This is x. This side is 150 plus y. So now I'm going to set up a ratio. Tangent 35 is equal to x over 150 plus y. So my goal here is to solve this linear system. This is a linear system in terms of x and y. So what I'm going to do is I'm going to cross multiply so that I get x alone in both of them. Okay, so let's do the work down here. So this is the setup. So now I have tan of 48 equals x over y, right? So I could just cross multiply and say, well, then x must equal tan of 48 times y. Then I take my other equation. I have tan of 35 equals x over 150 plus y. When I cross multiply, I get x equals tan of 35, and I must put the 150 plus y in parentheses. So both of these are standing for the same x value, right? Which is this x value here, which is what I'm looking for. So I'm going to set these equal to solve for y, and then I'll be able to solve for x. Now, I don't have to take out my calculator until the last minute, okay? I have tan of 48 times y, right, equals tan of 35. I'm going to distribute it, times 150 plus tan of 35 times y. Your goal in math is to get the like terms together, so I'm going to subtract tan of 35 times y from both sides. So now I have tan of 48 times y minus tan of 35 times y, okay, equals tan of 35 times 150. Well, I have two y's, so I know you learned this in algebra. If I take out a y, I factor it out, I have tan of 48 minus tan of 35 equals tan of 35 times 150. So therefore y would equal tan of 35 times 150 over tan of 48 minus tan of 35. But now keep in mind, I know that I have these equations for x. I can use either one of them. I'll use this one. So I have x equals tan of 48 times y. Well, y is all of this. So I have tan of 48 times tan of 35 times 150 divided by tan of 48 minus tan of 35. Now you can literally get in degree mode, go to alpha, y equals, and type in this entire fraction, and you will get your answer. So your answer is x is about, okay, I want it to the nearest whole number, so 284. Okay, that is one way of doing the problem. Some people find that complicated. I don't believe so. If you just keep everything separate, you already have these skills, right? So I will show you another way as well. So the other way to do this problem is by using something called the law of sines, okay, which you're not familiar with. I do have a video which I will share that I posted for 9 honors if you're interested in learning more about the law of sines. If you're not yet, that's fine. You'll be learning it next year anyway. Okay, so back to the original problem. I want to find x. So I have a completely different way that I could proceed. So I used the 2 right triangles in the last method. I could use this triangle and then use the right triangle on the right. So if I use this triangle, the way this works is, number one, I'm going to get whatever missing angles I can. This is 132. This is 13 degrees. Okay, so I'm going to call this side y. I'm going to solve for y using that triangle on the left, using something called the law of sines. So the law of sines works as follows. You take the number 150 and you put it over the sine of the opposite angle. Now, okay, you have on the other side, I have y over the sine of 35. So if you want to do it this way, now I'm going to cross multiply, so I'm going to get sine of 13 times y equals 150 times the sine of 35 divided by the sine of 13. And you could type all of this into your calculator now. So therefore y, okay, I'm just going to go to several decimal places, all right, is about 382.4675, because I don't want to end up with round off error. So now I go to this picture on the right. I'm going to take this triangle and I'm going to draw it down here now. I have that this is 382.4675, just about right. This is 48, and now I'm looking for x. So now I can just use sine. So I can say, all right, I have sine of 48 equals opposite over hypotenuse. And then I just end up cross multiplying. So x equals 382.4675 times the sine of 48. And this will indeed be what we got before, about 284. So it's up to you. You have to pick which 2 triangles you want. There's advantages and disadvantages to both methods. Some kids are not fans of law of sines when they're in, Common Core geometry. Some kids are not fans of the algebra, but you have to pick which method, okay? Like they say in life, you have to pick which way you want to suffer. Do you want to suffer through the algebra, or do you want to suffer through law of sines? Okay, whichever is easier for you. All right, I'm going to show you one more problem. Okay, this problem is going to be a problem-solving situation, but it's going to be instead with angles as the unknowns. All right, here we go. This is a projector problem. Okay, I'm not going to give you the whole context. I'm just going to teach you the skills. Okay, this little skinny angle here, I'm going to call theta. Okay, now my goal is going to be to find this angle here, which I will call x. Find the measure of angle x to the nearest degree. Okay, I have to give you more information. I have to give you information about the sides, right? So this is going to be 12, this is going to be 60, and this is going to be 75. So what I'm going to do here is I'm going to find this large angle, okay, which I will call y, okay. Then I'm going to find x. My bad, I want to find theta. Then I'm going to find x, and then I will be able to find the measure of theta. To the nearest degree, okay? So I'm going to set up these two triangles. It's easier to take the triangles out of the picture. I'm going to set up these two right triangles. This one with this angle that I call y. Then I'm going to set up another triangle with this angle that I'll call x. And then in the end, remember, theta is going to be y minus x. That's going to be my goal. So in the first triangle with y, this entire side is 72. This is 75. But in the smaller triangle, I guess I could do a better job making that look smaller, huh? Let me do that so that I don't end up confusing you inadvertently. Okay. So in this triangle, this is my x. It's a right triangle again, and this is 12. All right, so for y, I'm going to use, oh, this is 75. I'm going to use tangent, right? So I'm going to say tangent of y is opposite over hypotenuse. Then down here, I'm going to say tangent of x is opposite over adjacent. I said hypotenuse, didn't I? Sorry. Opposite over adjacent. So in order to get y would equal tan inverse of 72 divided by 75. You don't have to type it in until the last minute. X equals down here tan inverse of 12 divided by 75. So you can get the answer in one swoop because theta is going to be y minus x. So that's going to be tan inverse 72 divided by 75 minus tan inverse 12 divided by 75. Okay, pause the video and type this into your calculator. Then come back and round it to the nearest degree and see if your answer coincides with mine. So I got 34.7405, etc. 34.7405, yada, yada, yada. So to the nearest degree, that would be 35 degrees. All right, be prepared to discuss these questions more in class, and we'll try other problems of this sort, okay? Thank you very much.